When you start the line, it comes off as a product on the end of the line, 1 unit every minute. So it's very quick, very little labor commitment. So it's very productive for us.
Hi, this is Tim Heston, Senior Editor at the Fabricator magazine, and welcome to another edition of Automation Talk, a podcast series by FMA brought to you by Salvagnini America. This season, we're taking a deep dive into software automation, and in this episode, we'll be covering custom metal contracting, or CMC, a Calgary-based fabricator that fabricates and installs metal cladding systems for the construction industry. We'll also be talking with Matt Humerick, a software specialist at Salvagnini America, about the company's IIoT platform, Lynx. The two conversations represent very different stops on the software automation path, but each stop, so to speak, shows just how dramatically software automation in general is affecting production output. As for CMC, my colleague Rob Colman of Canadian Fabricating Welding magazine talks with operations manager Brad Shykitka about how the company transitioned from traditional fabrication techniques to a flexible manufacturing system integrating laser cutting and panel bending. For some work, the company went from shipping 8 panels a day to 8 panels in 8 or 10 minutes. That's a dramatic uptick in productivity, obviously, and it reveals something deeper going on than just simple cycle time improvement. It's about information flow, including what's decided, when and how exactly parts are released to the system. Today, when parts flow to the floor, all the manufacturability questions have been answered. As you'll soon hear, that fact has taken CMC a very long way in recent months, and the fabricator's just getting started. To get the full story, I'll let Brad take it from here.
We started our business in 1980 doing metal cladding as a install only, and then we gradually migrated into manufacturing, supply and install of cladding products, and then eventually into metal panel systems.
Now you have the Salvagnini Manufacturing Center. How does that change the layout in your shop in terms of the lines you have?
So basically, we have 2 manufacturing lines, which is the conventional method of routers and assembly tables. And now that we have the Salvagnini, that's a full manufacturing center. That's everything from laser to towers to Cartesians and a conveyor, rotator to rotate the material as you cut it on the face, and then you bend it on the back side of the panel, so it has to be flipped. For the pre-finished products, for the unfinished products, we don't flip them. We just send it directly to the P4. From the P4, it goes after it gets bent up. It goes onto an offloading table, which is basically just a glorified manufacturing assembly line. It's a finished product. When it comes off the machine, it goes into a crate or into post-processing for insulation or pins and or like stiffeners for the panels. When you start the line, it comes off as a product on the end of the line, 1 unit every minute. So it's very quick, very little labor commitment. So it's very productive for us. That encompasses the programming as well, right? So we have very little programming. Once we program that part once, we're done. We can, it's repeatable. We can stretch it, shrink it. It's the exact same part, it's just different dimensions.
As a company that's been around for as long as you have been, obviously you know your business, you do it well, and it's held you in good stead up to this point. What was it like to adapt to the process of using a software that's going to carry you through this whole process, and how has it changed the way you work for that?
It's absolutely a very big learning curve, but once you've learned it, it's repeatable for the next job. Once that whole line or batch of panels is programmed, it's very fluid after that. It flows and it starts at one end, comes off the other end, and it's a manufactured product. All of our customers, they're doing that modeling anyways for their products for the whole assembly. So they're just pulling that piece out of their assembly drawing and sending that information to us. So basically from there, that step file we can do it through the automatic programmer. So it programs the laser and it programs the P4. So now that we have that capability of sending alumina products directly to the machine with a step file, we'll be drafting those panels in that format and sending it directly to the machine for processing. So what you see on your AutoCAD inside the 3D modeling is exactly what the machine is going to produce. But with the step files, you're drawing that product in raw. You've got the exact model of that panel. We just send it through another processing center that automatically programs the laser and the P4 at the same time. The gains for our drafting are immense. We've minimized a lot of our time in drafting to send information to a machine that does the bending, does the cutting. We don't have to tell it how to do something. It does it, as long as we're following the exact protocol that we need to program the machine. So we've gone from a very manufacturing of 8 panels in a day to 8 panels in 10 minutes or 8 minutes. When we initially got the machine, and the owner of the company came to me, he said, "Brad, the machine is sitting. Why is it sitting? Don't you have panels to manufacture on the line?" And I said, "The products went onto the line, they're manufactured, they're sitting in the yard. I don't have any more panels to manufacture." So we went outsourced, or we looked out in the marketplace for back pans for other industries to get into to provide those products for them. So that took some effort to get there. We're getting there. We're not fully there, so but eventually we'll get the full capacity of the machine.
Having available capacity to sell is obviously a good problem to have. A real problem would have been having those machines sit idle simply because orders couldn't be fed fast enough. CMC took the steps to automate much of their order flow through software. With jobs flowing and shipping so quickly, CMC now has more capacity to sell and grow. When you think about it, software today really is in the driver's seat when it comes to a fabricator's growth. To explain why, we turn again to Matt Humerick, software expert at Salvagnini America. He'll bring us through what I like to call the trifecta of optimization software platforms that the industry is now seeing. First, you've got offline machine programming and simulation like Salvagnini Stream. Next, you've got production control software like OPS, which manages orders, raw materials, and optimizes information flow between ERP and the shop floor. Finally, you've got IIoT platforms like Salvagnini's Links. This measures machine performance in real time and gives vital data both to solve immediate issues, like this machine isn't performing like it should, as well as long-term ones. What mix of work, be it part geometry, customer demand, or trends, or anything else, performs best, and how can we replicate that performance? For fab shops with the right software, good data really shows the way. With all this in mind, I'll let Matt take it from here.
Yep, so we can talk about OPS first, and then we'll talk about links. When it comes to OPS, we generate the nesting, we send to the machine. But OPS is also connected to the machines. So it sees what's running on the machine and will generate reports and send back to your ERP system. And it will tell you, I produced this part. Now I produced this fullness. Now this is my efficiency of my sheet. This is the sheet that I used. This is the quantity of sheet that I use. Here's my scrap. Here's my total weight. It will give you all of that data back. That way your ERP can then manage the data and automatically inventory reduction or order new material to replace what you're consuming, right? So that's a huge thing. We could talk about links. In the link software, it's a IoT solution for Salvagnini. Data is always generated from our machines and outputted to the cloud. You can use our interface, you can connect, and you can see all of the production that you've made. You can see errors that have happened on the machine throughout the day. That way, if you're seeing a consistent type of a pop-up, you can kind of address that pop-up before it becomes a major problem. You can see the production times. You can see same thing that you can see from the OPS reports. You can see the parts you're producing, the quantity of each one. You can see your throughput. You can see an OEE. So the machines and software are so intertwined now that you can see the full processing without actually going and seeing the machine. So you can easily understand what's happening at your production facility without being there. So software is always evolving. So it can give you some predictive information, right? So it can tell you how long it took to produce a part, but it can also help you understand that if I run in a certain type of a way, this is going to be my efficiency on a sheet, for example, right? So you can see all of that data and track it back to what makes most sense for your business. But like you said, you can also use that data to say, hey, this particular kit would have took me 3 hours to make on a press brake. Well, now I'm making it in 20 minutes on a panel bender. On a business aspect, software is critically important because we want to know what's happening at all times in our facility. We want to know our production. We want to know how we can improve our processes, right? So with the software being what it is today, and it's only going to continue to grow, that information is going to be more and more readily available, which will then drive some other creation of other softwares to digest that data and see what makes sense. And then you can do like a estimated efficiency run. And you can say, well, if we mix these parts around in this type of way, maybe our production, instead of being 2 hours, it's 1 hour and 45 minutes. So those little things that you can do that don't seem very big and important can be big and important over the course of a year, for example.
Think of it as a virtuous cycle. It starts with dramatic improvements, such as the hours CMC saved instituting its modern machine and software platform. Much of that can be attributed to how information flowed from the customer and the automated machine. Without software, some incredibly efficient equipment would have been sitting idle. Over time, this grows to production optimization and refinement through production control and IIoT. Eventually, that trifecta of optimization software, programming, production control, and IIoT forms the foundation for growth, creating a virtuous cycle of production measurement and improvement. Related to this is how the next generation who actually grew up with software, who can't remember a time before the smartphone, will start to take software functionality for granted. Of course, part manufacturability is checked before it's released to the floor and simulated. Of course, programming occurs offline. And of course, machines report their efficiencies and effectiveness with every job they produce. To them, software really is a part of life. And for those in metal fabrication, software will play an ever-increasing role in life on the job.
Software is here now. Software is going to be here in the future. Software is a driver for all things in our life. It doesn't matter if I'm talking about machine software, offline programming software, or if I'm talking about your day-to-day phone usage. We need to embrace it more, we need to understand it more, and we need to grow with the software.
I couldn't have said it any better. Software automation coverage will continue with the Fabricator podcast, which should appear online soon. Until then, thanks for joining us for Automation Talk, and we'll see you next time.